Okay, welcome back. Now we will see how to convert a dimensional model to data vault. In a typical star schema, a fact table is surrounded by dimension tables. So in our scenario, we have a business model for insurance company, and in a simple way, the client would also apply for an insurance product for life, car, health or property from different sales channels. For example, she can apply from dealer or web portal or mobile applications of the organization. And result of it, a contract will be created for the client. So in here, suppose that we are required to convert dimensional model of the organization to data vault. We have a fact table that includes the transactional contract information, then the client, insurance product, and channel information as dimension tables. So let's start with the modeling steps. Okay, we obviously see that we have three main entities in here: client, channel, and insurance. So first we identify the business key values for these entities. To make it simple, we just use the primary key fields as business key, but please remember in dimensional model, we mostly use source system independent surrogate key columns in order to store each historical changes uniquely. Therefore, surrogate keys will not be a proper business key for data vault. Therefore, please do intensive investigation to identify the business key values for each entity. In order to keep it easy, we didn't use the surrogate keys in dimensional model and use primary key values as business key. After defining the business key values, then we will create a hub tables and add mandatory columns as well. So this step is straightforward and very similar to earlier examples. Then as a next step, that we will define the relationship between the different objects. In dimensional model, all relationships are established between dimension tables and centered fact table. If you have a snowflake model, then you would also have a relationship between dimension to dimension, but we will be just focused on the star schema right now. So we also know that in dimensional model, a fact table stores the transactions. And to model transaction in data vault, we either use transactional link or another alternative approach is creation of a hub table for transaction. According to first solution, we just created a link table for a fact table which is also surrounded by the hubs, and each hash key columns for hub tables inserted into the link table. Please take attention in here, as you remember that a transaction may be repeated for the same business key intersections. I mean, for this scenario, it's not very realistic, but still possible that the specific client would have a contract from the same sales channel for the same insurance product. So we need an identifier key from source table that makes our contract unique. In this scenario, we can assume that it is the contract number. We also refer it as a degenerate keys or dependent child keys, and we added this identifier to link table in order to make each relationship unique. Then another step, we will identify descriptive attributes and satellites for the client, insurance and the channel and connect them to relevant hubs. Then we need another satellite for descriptions of a contract like contract date and contract type, and after creation of it, we will hang this table to link table. Okay, now we first designed our model by using transactional link, but let's quickly look at the alternative solution. As we could create a hub table for transactional data, in here we generate a hub for contract and edit the contract number as the business key. And hash key of the contract table is also inserted into the link table. Then for descriptive attributes, again we created a satellite, but now we connected the hub table instead of the link. By this alternative method, we would model the transactions with hub instead of transactional links. So to shortly summarize, when we are converting a dimensional model to data vault, for each dimension tables, we create a hub table and one or more multiple satellites, depends on how big your dimensional table, and if requires that, we will separate the attributes due to rate of change. Then for the fact table, the first solution is you would create a link table to store the relationships of the relevant hubs, and if there are attributes exist to describe the fact table, Then we will also create additional satellite table for the link details. And alternative method is we can model the transactions with hub plus satellite and connect it to link table. Actually, second solution is more flexible and easy to automate because first option may be the only way if there is no business key similar columns like contract number or order number. So we design our raw data vault by converting from dimensional model, and according to guideline, the next step would be the addition of performance tables like point in time and breach, but our model seems quite simple and doesn't require. Then we will finalize data vault modeling with the creation of information marts. Because raw data vault is not recommended to be queried directly due to consisting many joins. Star schema or data marts will be recommended on information layer. To create star schema on data vault, actually it is very similar opposite approach when converting from dimensional to data vault. So we will convert hub and connected satellite as dimensions. Then the links and relevant hub and satellite would represent the fact table. We can virtualize these data sets using the views. And with this way, views can be quickly designed and present the data to specialists and the department by using any BI visualization tools. You can also store dimension and facts in the physical tables, and that would bring the faster query results, but on the other hand, it also requires additional data loading, data management, data cleansing, and hence the ETL processes. Therefore, views will be very helpful in here that we can quickly create a star schema on information mart level and allow end user to access data with supported visualization tools. Thank you for your time.